And then San Francisco happened. So there's stuff going on that isn't traditional people die, people get injured, but somehow is relevant for safety. And I just started broadening my horizons for traditional safety. But when you add machine learning, when you add AI, that computer is now taking on all the safety responsibilities that used to be the human's problem, that you used to be able to ignore, that you can't anymore because there's no operator.
Hi, my name is Junko Yoshida. I'm the editor-in-chief of Junko's Talk to Us podcast series. And today we've got this best guest that I can think of to talk about the safety. But in this case, we are asking him to talk about embodied AI safety. Here's Phil Koopman, Professor Emeritus at Carnegie Mellon University. Hi, Phil.
Hi, Junko. Thanks for having me.
Good. Well, this is the book, upcoming book. Book is already available now by the time this podcast goes out?
The book came out yesterday as we record this. So,
all right.
But only for my Substack subscribers. Everyone else isn't going to hear about it for a couple days. So.
Oh, okay. All right.
So yes, it's coming. It's out now.
Yep. It's out now. That's very good. So the point was that I wasn't going to start with this question, but I was thinking about it this morning. And the more I thought about it, I realized that I really have to ask this question. Why did you name this book Embodied AI versus Embedded AI? I mean, this is such an amateur question, but at the same time, I've given a lot of thoughts to this, and I thought that I should ask the author, what is really the difference between embodied AI and embedded AI?
Well, that question has several layers. The first layer is that my wife told me that I had to have the word AI in my book title. So the word AI is my
She's correct, yes.
She's correct, yes. But it's not false advertising. It really is about, well, not all of AI. It's about the machine learning flavor of AI. I took a course in AI, I think in 1981. It's been around a long time. But this book is about the new hotness, the machine learning, various flavors of it. Now, why embodied instead of embedded? Well, sort of there's no difference. I mean, an embodied AI system is an embedded system that has machine learning in it. So that early chapter actually goes through this and says, here's the definition. But embedded has been through a number of renames. There's this whole thing, cyber physical systems. And I can make fun of cyber physical systems because I don't think I ever got research money from the folks who had that program. Cyber physical systems was, we want to do embedded systems, but we have to call it something new. And in fairness, the folks who were really behind that wanted to bring more formality to it. And so there was some valuable, some academic thinking and rigor, and I don't have fun. I'm just making fun of something that was kind of serious. But every once in a while, embedded systems get called something new, so that there's new, you need a new phrase to get everyone's attention. So embodied AI, because embody is actually a legitimate term. I didn't invent it. In the book, I found that it goes back quite a number of years back to Rodney Brooks, he's the guy behind Roombas, it turns out. And so the folks who've been doing embedded system plus AI like to call it embodied AI. And I decided that was the most fitting term, the most apt term. I certainly didn't invent it, but it's a term that's getting more interest. The DoD folks call it physical AI. It ends up in the same place.
Okay.
But for our viewers, embedded systems with machine learning equals embody AI.
All right. Very good. I'm glad we cleared this out. But this is what I was thinking. The reason why I thought it was interesting is that embodied, if you use the verb embody, that means like it's the object itself sort of has this, it's not just embedded, has this characteristic to manifest itself to the outside world. And when you look at robotaxi, for example, it's not just you embedded AI in the taxi, but in fact, robotaxi itself kind of manifested itself in a strange the situation we had not thought about. And because it's robotaxi itself embodied AI, Am I getting it right, or am I overthinking?
No, I like that. I think the implication
Yeah.
that the when you say embodied, it evokes a different mental image than embedded. So I like it
Yeah.
because an embodied AI isn't just an embedded computer that sits there and, by the way, it has machine learning in it.
Right.
You have a thermostat that has machine learning in it. That's not what most people think of as embodied, but a robotaxi certainly is. So
Yeah.
you have these systems, and this is a book about safety. It's embodied
Yeah.
AI safety.
Yeah.
And safety implies that it's interacting with people and it could harm people.
Right.
And so that's more like robots
Yeah.
than a smart
Done.
light bulb, right? It's more like robots. Now, the safety is a continuum, and there
Right.
are bad things that can happen with pieces of equipment that just sit there for sure.
Yeah.
But a robotaxi is potentially a lot scarier than a light bulb, I'm going to say, right? So,
Yeah. Yeah.
so yes,
Yeah.
there's this
I'm glad we clear that out.
there's this implication that it's interacting with the physical world, and it's probably doing it with mechanical force as opposed to just information displays.
Ah,
That's what when you say embodied AI, people are thinking humanoid robots. They think of robotaxis.
yeah.
Even a Roomba starts
Yeah.
down that path,
Yeah.
right?
Yeah. So I think that actually goes to the heart of the matter. I have known Phil for over 10 years, and the reason why I followed him was the idea that I'm not just talking to a professor who has been deep in the weeds of embedded systems and technologies, but also
It's the
he
70s.
actually,
I started doing embedded in the late 70s. So yeah,
let's have it, okay.
a long time.
So you're not afraid to sort of building a bridge with other fields, whether it's a matter of law, whether it's a matter of social science, whether it's a matter of human psychology. You're not afraid to touch upon these areas that surrounds the embedded systems, no?
I I dive right in. But it's not someone who just picked up a book and read a chapter and said, all right, I'll write my book. I've been doing all these things for a really long time.
Yeah.
I started doing patent cases as an expert witness. Oh, I'm going to say in the late 90s, something like that. So I've been doing that for a long time. And then, as you know, I got into Toyota unintended acceleration cases, quite a bit later, but I'd already had a bunch of legal work in the patent area. So
Yeah.
I'm not a lawyer, obviously, but I've thought a lot about law.
Yeah.
I've been doing safety since the mid 90s on self-driving cars. I was doing security in the late 90s as well.
Wow.
So, and actually in the early 90s, I have a bunch of automotive security patents from the early 1990s. So I've been doing security for a while.
Oh,
I
I
don't
did not know
advertise it
that.
as
Yeah.
much. Yeah,
Yeah.
my specially created cryptography went in all the high-end General Motors cars in the mid 1990s. So
Wow.
I, legit the security jobs I'm going to
All right.
and the human computer interaction, I've always been a student of that. I got interested in that in the 90s as well. And for a long time, I had a human factors lecture in my grad course where I'd gone through some literature and I would teach a whole hour and a half lecture about human factors. So I've been doing that for a long time. So you put all these things together and then machine learning. Well, I coded my first neural net, I'm going to say in 1990.
Yeah.
Yeah, it had one neuron. It was pretty
Yeah.
cool. But,
All right. Yeah. 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 Yeah.
and I took a course in AI way back when as in my undergrad. So I've been touching and doing all these things for decades. And so in the book, there's well, let's talk about sort of the idea of the book, the thesis of the
Yeah.
book. The the idea of the book is if you want to understand embodied AI safety, well, first of all, you have to understand that safety is a thing because when you're interacting with the physical world, there's always the chance you can do harm.
Right.
And it varies from high risk to low risk, and that's covered in the book. But there's always the chance, and the scarier it is, the more careful you have to be with engineering. But to understand that really deeply, you have to understand safety engineering. You have to understand security engineering. You have to understand human computer interaction. You have to understand AI based on machine learning these days. And by the way, the law shows up. It interweaves.
Yes.
You have to understand all five of those things. So there's a chapter on the first four, and then there's sections on the law in the book. Uh, and it's not to make you an expert in any one of them, but rather, if you want to have an intelligent conversation about embodied AI safety, you have to know the basics in all 5 areas, or you just can't have an intelligent conversation. So the first part of the book is just to lay a foundation so everyone can talk knowledgeably, not about all the gory details necessarily, but some basic thing. There's this thing called perception response time. And if you don't know that, you can't talk about human interaction. And so I explain that what that is. And safety engineering is all about, yeah, people say it's good system engineering, but they're wrong. If you're not doing hazard analysis and hazard mitigation, you're not doing safety engineering. You're just messing around. Okay, so there's fundamental principles for all these things.
Right.
And I lay them down, and then I say, hey, remember all the robotaxi mayhem in California? I guess it was figurative mayhem, but until it wasn't, right? But there was a lot of craziness going on, and most of it wasn't what we expected to be safety issues. Most of it, there was the cruise pedestrian dragging mishap, which I put up as motivation early in the book.
Right.
But most of it wasn't people really being harmed, but
Right.
people still thought there were safety issues. Like, well, what was going on? Safety must mean more than severe injuries and fatalities.
That's a good point.
Right?
Yeah.
And so there's a chapter working through, well, here's what you should have learned from all the robotaxi stuff in California. And there's a lot of it that doesn't get talked about much.
No.
Just a really simple one. It turns out that parking in a firehouse driveway is not a good thing. But how does a safety engineer estimate the likely risk of someone dying because they parked in a firehouse driveway? Well,
Yeah.
you can't reason. No automotive engineer has the data and experience to estimate that, right? So there must be more to safety than just tallying up cost and severity and probability. There has to be more.
Yeah.
And so that piece just sort of enumerates, do you realize how big safety is? And we can look at the robotaxi experience in California and say, I'm just not making this up. This stuff already happened.
Right.
And it gets people kind of concerned. And it's
Right.
not because someone died. That isn't what happened in California.
Yeah. But it's sort of that's a representation of things that embodied AI start doing things that we hadn't thought about, right?
Right. And so the other part of the book is this is not a robotaxi book.
Yes.
The robotaxis are the grounding, the foundation.
Yeah.
What happens after that, I say, well, more generally, if you're building a medical device, you're building other devices, what are the implications? What are the broader lessons? And so it is not half medical, half robotaxi. Most of the words are about robotaxis. But I try really hard that at the end of every chapter, and sometimes at the end of every section, there's a let's step back a moment and let's reflect on what this means for things that aren't robotaxis.
Yeah.
And I've had another part of my life, I stopped counting at 200 design reviews. And that was more than a decade ago. I have no idea how many design reviews I've got. Get on a plane, get in a car. And I stopped counting because I just lost track. Get in a car, go look at someone's source code, go look at why the project had a near-death experience. And it goes from gas chromatographs to pipeline controls to electrical stuff, a little bit of aviation, a little bit of medical, lots of things that go boom if something's wrong. So I've seen a whole bunch of industry stuff, a lot of dirt on my fingernails. And so I bring that experience saying, well, yeah, I know about robotaxis, but I also know how a compressor in a house can fail. And I know how this other thing can fail. And so I pull out some general, I don't try and teach domain expertise in all of them. There's just so many different things. But I try and generalize and saying, here's a takeaway that if you're not building robotaxi, but you decide to put machine learning in, here's what you got to watch out for.
Yeah.
And so the book spends some very intentional effort trying to generalize the lessons so that anyone using the technology can learn from it.
That's great because, because everybody's talking about robotaxi, people think, oh, this is like a robotaxi lessons learned kind of book, but it actually goes beyond that.
Well, you've seen the book, right, Junko?
Yes, my book.
So this is not a theoretical discussion. Yeah.
Yeah. I got a lot of
wow, look at that.
Yeah, but if we didn't have the real world examples of robotaxis, I don't think your readers, myself included, really understand what's going on here, what needs to be watched out, that sort of thing. I mean, it's spoke to us really directly.
Well, let me tell you how I got here, because
Yes,
that all wraps into it. So I had the How Safe is Safe Enough book a couple years
yes.
ago at this point. And that was, oh, so the robotaxi guys said they're going to have positive risk balance, which means safer than human, right? What does that mean? Well, it turns out it means 350 pages of, are you kidding me? Wow, that was more complicated than I thought. Right? That was way more,
Right. Yeah,
which driver, in which zip code, in which car, and how old is the driver, and is it day or night, and, all. And
yeah,
if you want to really find out if your robotaxi really is as safe as a human driver, you need a
yeah.
super granular comparison for it to be a fair comparison.
Right.
And the industry since that time has sort of been working through that and getting better, which is great.
Yeah,
But then after that book came out right before all the San Francisco stuff started getting real,
right.
right? And then San Francisco happened and we just saw all these headlines and all these pictures. And I started also at that time, I started learning more about the legal stuff. I'd learned a little bit about legal stuff, but
Right.
at this point, I now have 3 law journal papers, which is 3 more than I ever expected I was going to have. Co-authored with Bill Wyden at Miami Law, who's a great guy.
Yeah,
He's the actual lawyer. But I learned about negligence and I learned about how this stuff interacts.
yeah,
And but I kept seeing these really embarrassing pictures in San Francisco.
yeah,
A robotaxi going into wet concrete, which really degraded people's confidence. But it's like nobody got hurt. I get that,
yeah.
but it's not a good look.
No, no.
So there's stuff going on here that isn't traditional. People die, people get injured, but
Yeah,
somehow is relevant for safety. And then the bad interactions with the emergency responders, and a bunch of other stuff. And I just started broadening my horizons for traditional safety really is what they were saying.
yeah.
But when you add machine learning, when you add AI, what
Right.
changes is you don't have a human driver anymore.
Yeah, right.
And
There you
also,
go.
when I
Yeah,
did the UL 4600 work, I said we should put legal liability. And they said, no, 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 that doesn't belong in a safety standard because that's the driver's problem. It's not our problem.
yeah,
Well, that used to be okay.
yeah,
But now when the computer's a driver, somebody's holding the bag, right? So when you replace the human with machine learning in any application, any embodied AI system, that computer is now taking on all the soft, squishy safety responsibilities that used to be the human's problem, that you used to be able to ignore, that you can't anymore because there's no operator. You have an airplane and you don't fly in icing conditions, okay? Well, there's a computer operated drone. How does it know not to fly in icing? Either some person is in charge of telling it not to, but the person isn't there, they don't know.
yeah,
Or the computer has to figure it out, right? And so
yeah,
there are all these aspects, or what about after crash? Who helps who notifies the police and who helps the victims? And either there's a remote human operator or the computer has to do it, but the computer has to know to tell the remote human, hey, pay attention. So all these things that we just take for granted in safety go away when there's no human operator. So this book is what I've learned since I wrote the last book.
yes.
And the big lesson was you have to really greatly expand your concept of safety way beyond the usual functional safety. So in functional safety, you worry about faults inside the system,
Hmm.
okay? And the SOTA folks, safety independent function, sort of get at, well, things can be unexpected in the outside world, and you still have to be safe. And I expand that to say, well, for an autonomous system, you have to worry about faults inside the system and you have to worry about faults outside the system too.
Yeah, outside system.
If there's
Yes.
just something just went sideways in the real world in a way your designers didn't anticipate or in a way you didn't train it, your training data doesn't represent.
Yeah, yeah,
You have to deal with it. And I'm not just talking about the car in front of you moved in a weird way.
yeah,
I'm talking about all sorts of things, right?
yeah,
And people are pretty good at, I don't know what that is, but I'll muddle through somehow.
yeah.
And machine learning's not.
You know, therein the problem. I mean, I think that the world does not go from 0% automation to 100% automation. We are in this long slog of a little bit of automation here, a little bit of automation there, and things are advancing levels, right? Just like
Yep.
video games.
Yep.
But now, because we are in this transition period, and we may never get to 100% autonomy anyway, but
Not anytime soon. That's right.
right?
Yeah.
So
But that's okay. That's not wrong.
that
That's not
doesn't,
bad.
yep, right.
It just, it is what it is. And you have to, if you want to make money doing this, you have to recognize that's the case.
Exactly. So if so, though, I mean, during that transition period, uh, people already in always in the loop in a way that whether it's being affected because they are outside the robotaxi or they are actually safety drivers. I mean, they're whether it's a robotaxi or not. I mean, embodied AI systems are out there and interacting with people, right?
Yeah.
So that is the area that we haven't really studied. I was just a reporter, right? So every time something happens, I write about it. Oh my God, I had not thought about, right? And just writing a news story, but I realized that that needs to be kind of systematically explained and really needs to be learned.
Well, I spend a lot of time on that in the book. There's a reason there's a human computer interaction chapter,
Yeah.
but it's not just the chapter that I just set by the side and keep going. Uh,
Yeah.
the reality is that humans will be interacting with these systems for the foreseeable future. But it's a little trickier than that. Some of them will be other people interacting, sharing the space. So in the robotaxi area, there's human-driven vehicles, right?
Yeah.
But there's other people who interact. The remote support people interact with it.
Mm,
If you have cars that are not, that are robotaxi wannabes or not robotaxi wannabes, but really sophisticated computer driving, you have a person in the car whose job is to watch the computer.
right.
People are terrible at that. Okay. And it also brings into these really tricky questions about liability, sharing liability, and who's
Right.
really blamed. And there, I have a section on the moral crumple zone. Briefly, well, we're going to
Yes.
build this dangerous piece of automation, but our plan is to blame the person when it fails.
Blame the person. Yes.
And
Yeah.
and we absolutely see that in action right now.
Already. Yes.
All this stuff is in the book, and so I say, well, here's how humans fail, and here's what humans are good at. Here's how automation fails, and there's a section on open challenges, which is how do we deal with the fact that automation fails in a way that makes it hard for humans to pick up the pieces. How do we deal with that? Yeah, the worst thing you can do is give a human a really boring task that a machine does almost perfectly, but when it fails, it's, you could die.
Yeah.
And I just described a lot of high-end driving automation, didn't I?
Yeah.
But what if it's something else? What if it's, it doesn't have to be, well, I mean, there's the whole aircraft thing, which isn't that different in that respect. But
Mm.
what if it's a diagnostician that you have a device, a medical device,
Hmm.
and it's looking for symptoms and it's almost always right. And it says, yeah, everything's fine, even though it's not. And
Yeah.
some person is supposed to be watching the stream of data, and it's like the computer says it's fine, right?
Yeah.
And maybe the guy gets fired for overruling the machine because there's loss of revenue from every time he does a safety shutdown.
Yeah.
Maybe it's a chemical process plant. Maybe it's all, all these things. Maybe it's a nuclear power. If you have automation complacency and automation bias where the person has trouble really paying attention, they lose situational awareness, they lose skills because they're not operating the plant, and they could get fired for shutting down the plant when they don't have to and the AI said not to. Man, so one of the things I like saying is you get what you incentivize. If you
Yeah.
incentivize people to not touch the controls and they don't touch the controls, why did you expect anything different?
Yeah.
Right? And so there's all these things. It isn't just people watching autopilot. It's a more general thing that asking people to pay attention to boring automation that almost always works except when it doesn't,
Yeah.
and lives are at risk.
That's
You're
catastrophic.
you're
Yeah.
asking for trouble, right? And so
Yeah.
the book sort of works through that's an issue. Now, maybe there's ways to solve that. Maybe you can get a good operation monitor. So every time I say driver, just say operator instead, And sometimes I go back and forth. You can get a monitor that monitors the mental state of the operator by
Yeah.
cameras and whatever else. Okay.
Yeah.
Yeah, maybe you can do that, but you have to realize that this is a thing. You can't just say, well, we'll just blame the driver and everything's solved, because that's not going to solve it.
Yeah. The interesting thing is that I've been working with this AI from Toy to Tools video podcast series. And every
Yeah.
time when this issue of how you deal with really the interaction between human and the machines, the, people, I think this is fascinating because these are all experts. They're trying to bring AI into their own domain. And yet they're over saying, well, Junko, there's a solution because we can have AI watching AI. That's like a new sort of workaround. They don't have solutions, but that's like their dream. If humans can't watch this so intently, we'll have AI watching AI. What do you think about that?
Well, I think the issue is anything based on statistics has trouble with heavy tail, long tail, rare
Yeah,
events.
yeah.
And how do you, and the main system is going to fail on rare events. And how does the watcher know that it failed?
Right.
How do you make sure it's not unaware of the same rare events, especially if you train it on the same data?
Oh,
How,
that is true.
if there's
They're
a
not
rare
on the same
event
page. Yeah.
nowhere in the data, how are you supposed to know that you ran into a rare event? I don't get it.
Yeah.
So
Yeah.
when you're doing conventional software, you look
Yeah.
for common cause failures, a
Right.
single
Right.
thing that will cause both to fail.
Right.
And
Right.
for machine learning, watching machine learning, or having two machine learning and comparing, but they always have different answers, that even's complicated. Okay. But having machine learning, watching machine learning, the common cause failure is there's something not anywhere in the training data that's still safety critical, and neither one of them are going to know about it. Maybe they guess differently. Maybe you get lucky. And
Yeah.
it's okay to take statistical credit for getting lucky sometimes, but it's not a guarantee.
Not guaranteed. Yeah. All right. Well, this is very interesting. One of the things actually, I've been talking to industry analysts and the people who are supposed to be in the know, judging where we are with automation technologies. And they often, come back with this question. And I think you actually really ask good questions in your book is that why do you believe you're safe? And why should we believe you're safe, right? I mean,
Right.
these
Yeah.
are the two questions that I'm just a reporter. So I actually use that as a yardstick. Why should I believe you? What you're saying is really this thing is very safe. But even the world itself really needs to be able to ask that question. What would be the right answers then?
Well, there are two levels of right answer. The first is everyone else in the world except the car companies follows international safety standards, and that's the reason you believe they're safe. So there's that. But the safety standards for other applications are going to equally have problems with using machine learning,
Right.
because the typical safety standard will either say don't use machine learning, or if you use machine learning, it completely undermines all the assumptions which revolve around, but there's a person there to take the blame, and you can still blame them, but it's not going to do you any good because they have no idea what's going on here. They're not paying. They're not able to effectively supervise. So the more general thing is you need AI safety standards, and they exist in automotive. They don't really exist in a lot of other domains, so that's still to come. Uh, but beyond that, the last chapter of the book, I want to make sure everyone knows this isn't just a book about problems, right? There's a book about principles, but there's a chapter about solutions. The last chapter is, well, how do you build justifiable trust in this technology?
Yes.
And the answer is not promising saving lives, because it takes you 10 years to prove it. And every photograph of a robotaxi making a mistake, crashing into a telephone pole or crashing into a fire truck, those are real.
Right.
Every one of those degrades confidence. And you say, but trust me, bro, in 10 years, it'll save lives. Yeah, but you just crashed into a fire truck. Why should I believe you?
Yeah.
Which is the version of the question you asked. And my answer is stop promising saving lives, because that is all downside, no upside. It sounds great when you're raising venture capital to begin with,
Yeah.
but the proof takes too long.
Yeah.
For the near future, it's all downside. And so what do you do instead? Well, the chapter talks about how you can build trust. And you build trust by making realistic promises, by taking a proportional responsibility for bad things instead of, well, it was 49% our fault, so we're blaming the other guy 100%. I'm not making that one up either. Okay. That kind of deflection and say, look, we're a perfect driver just gets eviscerated every time there's a bad news photo. And the
It
bad news
happens,
photos,
yeah.
and when you say that, you're setting yourself up for, well, if somebody said they're perfect, of course I'm going to look for bad photos to prove them wrong, right? What were they thinking when they did this, right?
Yeah,
All
right. I
right.
know that's
Well,
true.
it's just because it's the standard playbook. Tech is going to solve all our problems for free instantly, all that. And that's just
I
not the
know.
real world. But instead, you can say, well, yeah, someday we'll save lives. And here's our 10-year plan for that. And we're on track, but we'll see how it turns out. Meanwhile, we promise to be conspicuously good uh, public citizens, that we're going to be really good at road use. And every time we make a mistake, we're going to find the mistake, we're going to fix the mistake, and we're going to make public the proof that we fixed the mistake. So if you're people in the robotaxi business like making, well, it's a teenage driver, he's still learning. Say, yeah, but they learn faster than what we've been seeing out of robotaxis. It doesn't take them that long. By the time you're 25, you're a really good driver. Okay, much
Yeah.
better. And one company will claim that's true. Most of the other companies aren't there, right? It's taking a much longer time, and every
Right.
company's different, so you can't use one to judge the others. So instead, what I say is, well, what you should do is say, here are the metrics that people care about, like how often do we block a fire truck? Why aren't they publishing that metric? Because if they're getting better at it, the metric would show they're getting better.
Yeah.
But they have this public relations thing that we never make a mistake and it's always someone else's fault. And it's hard to back down from that. But if you want to build trust, why would you believe someone who keeps saying it's never our fault and then there's a period of saying, I don't
Yeah.
think so.
There you
Instead,
go.
be
Yeah.
a little more transparent, admit you're not perfect, but make the sale not on saving lives, make the sale on we're pretty good and we promise to get better, which is a message you also hear that it'll always get better.
Yeah.
Okay, well, if you want us to believe that, show us some data.
Trust.
Show us the video from the test track of it not making the same mistake.
Yeah.
Here's the video of
Why
it
not?
making the mistake, and here's the video after it got fixed and it won't make the
Yeah.
mistake. One more mistake checked off. Let's
Yeah.
keep going.
Yeah.
Right?
No,
There are ways to build trust. That's one of the techniques. There are a bunch of ways. So the last chapter uh, sort of puts out here are all the things you can do to
mm,
build confidence that don't involve making crazy promises that are going to take 10 years to see how it turns out.
all right. No, that's a very good summary. In closing, Phil, I'd like to ask, what sort of people do you want them to read this book? For whom did you write this book?
Well, I wrote it for you, Junko.
Great.
I say, what would Junko want? There are for sure a couple sections that get pretty gnarly on a technical basis. And one of them, there's even says, if this is heavy sledding, just skip ahead. It's okay. Here's the summary. Skip ahead. There's one section about that, and I think that's probably the liability section because that stuff gets pretty dry. But it is for people who are technically savvy but are not specialists. How many people know safety engineering, security engineering, machine learning, and human factors? That list is pretty small. So it can't be for specialists in that area. It's more generally people who are technical journalists, who are engineers, who have maybe deep expertise in one of the areas and can point out all the places where, well, it's 99% true what he said. Yeah, but I'm talking to Junko, so give me some slack here, right? I know there's a special case, but it doesn't matter. Or there's a footnote saying, yes, there's a special case, go ahead. I know there's a special case, right?
I have to tell you, my guilty pleasure reading reading this book is like looking up the footnotes. Footnotes are so much fun.
Good. Well, I'm glad you find them fun. I try and make them fun. Yeah.
Yeah. You're quoting Blues Brothers,
Right. Well, why wouldn't I? You have to have some fun in there. And there's some Easter eggs. There's pop culture references that are cited to make sure people get them. But there's some Easter eggs where there's a pop culture reference that I didn't cite. So you can
we should do a quiz.
Anyway. Yeah, we can do a quiz. So let me wrap up. The audience is journalists and regulators and legislative support staff. And there was a Washington legislator who actually read my Safe Enough book. And I don't want to embarrass her, but I really appreciate she did that. So someone who really wants to go into it, there may be a couple sections that are a little too deep, but anyone who really wants to understand the technology can get something out of this book.
Yeah.
And someone who's been studying the technology for a long time, I think will get a lot out of it in terms of insight on, safety. Safety is a lot deeper and a lot broader than most folks appreciate, but you can't leave any of this stuff out if you want to deploy at scale. On day one, sure. But this is what happens. What does safety mean when you have a million of something? Well, there's a lot of safety when you have a million of it, because all sorts of rare events matter, but also some secondary interactions also matter. And so things that typical safety doesn't deal with, they're going to be in the news, and it's going to be your company's name in the news. So you better pay attention.
All right. Very good. Well, thanks for coming to the show. And I'm really glad that I have this book, and I would recommend everybody to get this one. Anyway, thanks for coming to the show. We'll talk soon. Okay.
Thanks, Junko.
All right. Bye.